We're now going to provide definitions related to matrices and invertible matrices. And so what we're talking about here, we're going to start by multiplicative inverse. And that says if we have a number a, then we want to know what we multiply it by to equal 1. And so we use a negative 1 because a times a to the minus 1 is a to the 0, which is 1. So multiplicative inverse is the number that I multiply by to get 1, and it's always the inverse of that number. Well, matrix inverse is similar, but we need to add a definition here. I'm going to talk about the identity matrix for just a minute, then I'll come back up here. The identity matrix is defined as ones along the diagonal and zeros everywhere else. And in particular, this has to be a square matrix. And it says that it's in reduced row echelon form, and every row has a 1, has a leading 1. So a matrix inverse is what do I multiply A by so that I can get that identity matrix? What do I need to multiply by so that I get this guy, somebody with ones along all of the diagonals and zeros everywhere else? And a matrix is said to be invertible if it has an inverse. In other words, if I can multiply something by something else and get the identity matrix, then it is invertible. That's also where singular and non-singular come in. Singular is something that we say for a matrix that does not have an inverse. So this is a square matrix with no inverse. And a non-singular matrix is a square matrix with an inverse. And so that's what we're looking at. These are our definitions that we need: invertible, inverse, singular, non-singular.